You may have heard about a term called as computer vision, and many of us might also be working on this field. In simple terms, it's a field of AI which teaches a computer how to see. It is same as how we have eyes and our brain processes the data to understand the surrounding. For example, I might be seeing a pen and my brain processes that signal that it is a pen and can take necessary actions such as to pick it up. Some common tasks in computer vision are image classification, object detection, and segmentation. So let us find out how it works. First, we have an image capture sequence. This can be a CCTV camera, a GoPro, a webcam, or any video recording devices. Input from this might be an image which is been sent for pre-processing and feature extraction. When we speak of pre-processing, it might be resizing of the images or color conversion, and we utilize CNN models such as YOLO V8 to extract the features. Once the feature extraction is been done, the input from this is sent to the decision making. In decision making, we design the algorithms required. Let us understand about the models which are offered by the industry. We have models such as YOLO V12, YOLO V11, YOLO V8 or YOLO family for doing object detection. It is nothing but detecting an object and providing its bounding boxes, and it operates on 80 classes. Then we have segmentation model from the YOLO as well. We have instance segmentation which provides the actual mask for the object, and YOLO also provides us the option for YOLO pose from which we can actually find out the body key points. Similarly, there are many such models. Let us consider that we want to test the model. To do that, first step would be setting up the environment and installing the packages. Then, once the environment is been set up, we have to import the libraries and load the model. Once the model is been loaded, we have to take the data as an input, provide it to the models and do the inferencing. Post that, we have to process the output and display. It looks very simple, but to do all of these things for different models requires different environment settings. And sometimes we only require these models to test out, which is clumsier. So what if there is a tool with which you can add your data? Data might be a video for this example, and select the required model from the registry. And once the model selection is been done, you can get the output with which you tested the models on your own dataset. What if I tell you that there is a tool which can do this? And let me introduce to you a tool called as CV LaunchPad. So in this video, I will just demonstrate a PRD document for the version 0.1. Let's get to it. Let us start by understanding about the overview of this project. This is a platform where you as a user can upload a video. Once the video has been uploaded, you can then select the model and the required settings for that and start the inferencing. Once inferencing is been completed, you can view the results in a video player like format. YouTube is an inspiration where the user can play and pause the video, view the outputs frame by frame, and delete the video or individual model output. Very simple. So let us start with understanding the high level architecture. So the first thing is we need to upload a video. We will start with this itself. In the front end, we will have an interface to select a video from local storage. So it's a file picker. This front end will show the progress bar to represent the video upload status. We are going to use HTTP based file upload. Once the video is been uploaded, a button to open the next UI appears. It looks simple, but let us understand about the backend as well. First, we would require a post API called as video upload. This API will first generate a ticket ID for that video. This ticket ID will be used to structure our folders, in which we are going to store the original video. Once the video saving is been done to the server, we are going to insert the record into the database. Then the API will send the response, whether the upload was successful or if there was any error message. Now the video upload is been taken care of. We are going to move with listing all the uploaded videos to the platform, to which we have one more get API. This API will list all the videos which have been uploaded to the platform. With this, we have covered the video upload. Now let us understand what happens after that. So now we have created the video. I would like to do inferencing on that video. So let us understand about this pipeline. For this example scenario, that is version 0.1, we are going to work with only single model. Front end is very simple in this segment. That is, we are going to make an API call to get the model lists from the backend. With this model list, now the front end knows what are the supporting models. It will have an interface to create the task, wherein the user is going to select the required models and its respective settings, such as at what FPS he would like to process the video, etc., and make an API call to create this task. Now the task has been created, so there should be one more API call to get all the created tasks. Now let us understand in the backend what is happening. We have the get API to list the models. It is simply going to return all the models which are registered into the platform. Then we have a post API which is creating the task. When it is creating the task, it will accept video ticket ID, the model which the user has selected, and the desired FPS in which he would like to do the inferencing. Then this API will insert the data into the database and the status is changed to queued. Then it adds this query to Celery for backend processing and returns the success or the error message accordingly. What Celery will do is, it is going to load the settings from the database, use FFmpeg for now to convert the original video into small chunks of 10 seconds each, and create a manifest file. This file will have the details of how many segments have been created and what is the length or duration of the video. Now the status will be changed to pre-processing, which means the original video is fetched and chunks are getting generated. Once the chunks generation is completed, it is going to load the manifest file, check if the model is present, and if not, it is going to download the model, and once the model download is ready, it is going to load the model into the memory and start inferencing on the created chunks by the user. So the status will be changed as inferencing. Once the inferencing is completed for all the videos, then the status is changed to completed. There is an get API to get all the tasks which has been created. This simply returns the task ID and the corresponding status. With this, we have completed the creation of tasks. The backend is actually handling all the inferencing and processing, where you as a user have only selected the model and provided your required settings. So now the next interface would be to visualize the outputs. In this, the front end will be a bit more complex. From the tasks page, when you click on show results, this will call an API to get the manifest file from the backend. So let us first understand about the manifest file. The manifest file will be having something called as a segment duration, which is a chunk of 10 seconds each. The desired FPS which was requested, that is, this chunk is in 25 frames per second, and all the segments which have been created. The front end will load a set amount of chunks first, maybe 3 to 4 chunks. Then the video playing will start. In the video playing, from the front end point of view, we will be having features such as playing and pausing the video, controlling the video timeline with the slider, skipping to the next chunk, that is, skip the video by 10 seconds, changing the playback speed of the video, and when the video is paused, frame by frame navigation. Additionally, the interface will also have filters such as confidence based filtering, wherein I am only interested to find out the objects which have certain confidence, setting the minimum and maximum bounding box width, and visualizing only the selected labeled objects. And the backend will only function to serve the video requested, return the manifest file, return the metadata. And with this, our version 0.1 is ready, wherein we started by the file upload, then proceeded to creating a task and visualizing the output. In the next series, I will be starting the development of 2.1, which is video upload. Then we will proceed to the 2.2 and 2.3. So stay tuned and I will see you next time.